Okay, hello everyone, and welcome to the final Computer Vision in Production SOD.AI Social of 2020. First off, I'd like to introduce Rachel Roberts, who will be our sign language interpreter for tonight's event. Now, before we go any further, I just want to share some small announcements and updates about the Computer Vision in Production webinar series. So over the last couple of months, I've also been meeting and interviewing a lot of leading computer vision professionals across Germany, and we have been starting a podcast series also to the tone of computer vision in production. So you will find from January 2020 some really interesting interviews called the Computer Vision in Production Podcast Show by SOD.AI Social. And we have guests from companies like Hensoldt Ventures, Blick AI, Moon Vision, and many more. So the goal is that this podcast series will start to stream live in January 2021, and it will run through the 2021 calendar year. Of course, for any of those who may be interested in being a guest or would also like to recommend any guests in the future, feel free to drop me a message. Now, for tonight's webinar, we have 3 technical speakers. Each speaker has been allocated 30 minutes for their presentation. This is to allow them time at the end to answer questions of the talk. However, if during the presentation you do have questions, feel free to ask them during the talk and we can answer all questions at the end. As well as this, we've also allocated an additional 20 minutes of Q&A at the end of the final talk to ensure that we do not forget anyone's questions. So for tonight's agenda, our first speaker will be Rodrigo Mallen, who's going to be talking about the importance of camera and lenses selection for a computer vision engineer, which is going to be followed by Junli Tao, who will speak about hand detection model development. And then finally, we have Jan Zwandatsky, who will speak about the do's and don'ts of delivering AI projects and the fundamentals of ideating, evaluating, and scoping AI projects. So without any further delay, I'd like to allow Rodrigo to take it over from here. So for those who don't know Rodrigo is a computer vision engineer at AutoOne. He has more than 8 years experience developing computer vision solutions and deep learning. At AutoOne, he is working on the area of bodyworks. So it's damage detection for the automation of used cars inspection and evaluation. So from here, look, Rodrigo, if you want to take it away.
Yep. Well, Anthony, thanks a lot. Thanks a lot for having me. Nice introduction. And yeah, let's get straight to the topic. I would like to talk to you guys in this occasion about the importance of hardware selection in the sense of lenses, cameras, and a little bit, we will be talking a little bit about lighting systems, illumination systems. Why I decided to go through this topic? Because in the last few months, we have been trying to recruit some professionals in the area to join our team, and we found that although there's a really nice expertise in topics related to machine learning, deep learning, and also classical computer vision in general, there's a little bit of a lack of knowledge about camera selection, hardware selection for applications that require more of a controlled environment. So even though nowadays the world of computer vision is like full of wizards, I would say, really impressive people that can make a lot of contributions to the field. In the software side, there are also applications at this point that really require specific cameras, specific lenses, specific illumination, and it's also really important to get to know a little bit about this. So I wanted to make this presentation a little bit more friendly in the sense of math and technical stuff. So let's go for it. Okay, I hope you guys are all watching my screen. So yeah, let's get into the topic. So basically, what implies to have a good or an acceptable computer vision system or machine vision system. Basically, everything is related to the image quality, how the end result is going to be. So a successful vision system means, in terms of hardware, basically image quality. Let's say this trade-off, this balance between the camera selection, the optics, the lighting system, and also the interface of the camera that we're going to be working with. Image quality can be also translated or can be reduced, so to say, to these subtopics, these topics like brightness, contrast, sharpness, sensor and pixel size, quantum efficiency, dynamic range, image to noise ratio. So these are concepts that most of the time are related to the image sensor, but nonetheless, we're going to check how, for instance, a sharp image or an image with a good contrast also depends a lot on the lighting system we're using and the optics. So first of all, let's try to get into what is quantum efficiency. All the following slides that I'm going to be presenting are actually related to, as I was mentioning, to the camera in this sense, and the lens. And the sensor. So if we put together all these topics, we will see at the end that we can actually check them all the specifications in charts that you can easily find in the manufacturer's websites or so on. So what is quantum efficiency? So, or a spectral response also. Quantum efficiency is given in terms of percentage. And it's basically the ability of the sensor to turn photons, incoming photons from the source of light, to electrons. So it's basically this translation, so to speak, of how many photons impact our sensor, our camera sensor, and how many electrons are actually produced as a signal coming from the photons. No, so this ratio is what we call the quantum efficiency. Of course, the higher the better. We can see here on the right hand side some charts, some comparatives on different sensors on the market nowadays, both for CMOS in global shutter and rolling shutter mode, and also for CCD. I mean, CCD is so it was like so low in this chart that it was not even appearing here, but it's really important for an application. For a computer vision engineer, it will be really important to know if the camera that we are selecting has a high quantum efficiency, mainly for applications that require low light. This is really important because a camera with a low quantum efficiency could actually lead us to a really poor signal at the end of the day. So, as you guys know, nowadays CMOS cameras are quite more in production than CCD. One of the reasons is actually because of the higher sensitivity in quantum efficiency in the CMOS sensors compared to CCD ones. We can actually get more involved. We can get more into this topic. You can also check these links down here. This presentation involves a lot of deep topics, but I don't want to get so deep into them. I just want to give you an idea on why it's important to really take into consideration the components, the hardware components on our cameras and lenses. So another super important thing is the sensor size. It's not the same having a 40 megapixel camera in a cell phone than having, for instance, a 5 megapixel image sensor in a machine vision camera. Although at first glance it might be kind of counterintuitive, it turns out that most of the sensors, or most of the cameras in cell phones and IoT devices actually contain really small sensor sizes. So it's really important to take this into consideration, because the higher the sensor size and the higher the pixel size, the better. Why? Because as you can see in the right hand side, each one of these cells, that we will be calling them photosites, each one of these photosites is actually gathering the light, and the smaller these cells, or the smaller these sites, the less valuable information we're going to be collecting. So of course it's more important to have a sensor with a large size and large pixel size. Yes, also because in this sense we are also contributing to have a better signal to noise ratio. There are two factors that are actually entangled in some sense. Dynamic range is also a really important topic. We will be defining it as the ratio between the minimum and maximum detectable light intensities. Okay, and maybe you have heard about this concept so many times before, but I think one important thing to mention here is that a lot of machine vision cameras are also able to modify. You can actually fine tune or set certain bit values in the ADC, in the analog to digital converter of the camera. What this means? This means that it will be not only a matter of the bit depth of our image. Let's say that we want to have an 8-bit image, for instance, in grayscale, like you can see here in the right hand side, or let's say that the camera is also capable of delivering color images via a Bayer filter, or so on and so forth. It's also a matter of the ADC. So there are, as I was mentioning, there are certain brands that let us modify this ADC value such that we can also get a higher or a lower dynamic range. This will depend totally on our application. But why is it important to tune it? You might think at first glance that the higher the dynamic range, the better. Well, yes, but it again depends on our application. For instance, for an optimum image quality, the sensor bit depth should be set to a high value, as we can see here in the lower, in the right low corner. A higher sensor bit depth can improve image quality because the camera's internal image calculations are based on a higher bit depth. But if our aim is to get an optimal performance, we can also set the bit depth to a low value. This is because the readout time of the sensor is shorter. So yeah, let's try to consider these points when you're selecting your camera as well. And okay, so moving on a little bit to image noise, to what image noise and signal to noise ratio means. Out there in the market, there are a lot of, for instance, a lot of cheap cameras, you know, that at first glance, they claim to have a good performance in terms of, for instance, of resolution or frame rate, for instance. And if you're not an experienced person in terms of camera selection, you might think that, okay, I will go with the cheaper one. It's the intuitive way. But it turns out that Some of these cameras actually have a low signal to noise ratio, sorry, a low. The higher the signal to noise ratio, the better. What this means? It means that at the maximum and minimum values of pixel saturation, what we call pixel saturation, the difference between the true signal or the true information that we want to acquire from the images and the noise. Let's understand by noise everything, any kind of noise. This also implies like electrical noises, any kind of noise you can imagine. Let's say the summation of all those noises, how this overall noise will impact in our information. So the way to calculate it is pretty easily. It's like basically it's the ratio between the signal and the square root of the summation of the square noise, because we are basically taking into account all sort of noises. So as you can see in the right hand side, there are two images of a typical industrial application. This is an under vehicle inspection system. Okay, as you can see in the upper image, these images are actually used for detecting whether or not a vehicle has some foreign object, like, for instance, packages of drugs. In the case of my country, it's pretty common. Weapons, explosives, and so on. And as you can see in the comparison of these images, the one in the upper side is actually not so clear. It has really a lot of noises, and even the color is not the true one. It's not the real one. In the lower image, you can see an image with a high contrast, a lot of sharpness, and this is the sort of images that we expect to collect when we use a high quality camera. The two images were actually produced with under the same conditions. Let's say they were placed in exactly in the same spot, but using different cameras, and actually the same source of lighting. So this is really important to know, like how is the impact of the SNR and other topics and other features. Okay, next, the interface. How exactly we're going to be connecting our camera to our computer or to our frame grabber or so on. Nowadays, I would say that one of the most popular ones is the USB cameras, USB 3 mainly. And why they're really popular? Well, basically because they're plug and play, first of all. It has become one of the most common standards. It's also pretty new. You can actually connect it to your laptop and you're good to go. It's also a high-speed interface. You don't need frame grabbers, which is a really nice feature. Also, you don't have a high CPU load, and well, the easy of usage. The one con about the USB cameras is that the cable length, or the maximum distance you can actually connect your camera to your computer or whatever, it's actually pretty short. We're talking about something in the 8 to 10 meters, as you can see in the chart in the right hand side. Okay, so this is, in my opinion, one of the not so nice things. And the second point, we have the camera link interface, which actually can deliver a really high data throughput. Nonetheless, you require a complex system in the sense that you require a frame grabber and sometimes other sort of connectors. Nonetheless, there are applications out there in the market that require line scan cameras if you're not so familiar with lens scan cameras, please feel free to comment it in the questions box, and I will be happy to answer it at the end of the meeting. Yeah, but we're talking about frame rates higher than 1000 for typical applications of, let's say, notes or bills inspection, newspapers, and so on. And then we have the GigiVision interface. This is by far the fastest growing interface in the market. Me personally, I'm really happy with this interface. First of all, because of the simplicity, the flexibility of usage, the possible cable lengths that we can use. Just with a single cable, Cat6 or higher, you can easily get 100 meters of distance, but you can actually, if you use, for instance, a repeater, or if you use, let's say, 2 or more network switches, you can, of course, grow it by quite more than 100 meters. The bandwidth is also nice. It's not as high as USB, but it's enough for a lot of applications, like actually, like some of the applications I have been working in the past. And well, finally we have the firewire. The firewire interface is pretty old. It actually was pretty popular in the early 2000s, but nowadays the USB 3 is the direct replacement for it. So yes, I was saying, in the right hand side you can see this chart where you're comparing all the possible interfaces. Here there's also another interface. We can actually consider it another interface, although it's categorized inside the serial interfaces, which is MIPI, okay, and some other variants of it for IoT devices, cell phones, and so on. But well, I didn't want to get into that topic because here I want to talk about specific applications, more industrial applications that require specific hardware. Nowadays, all of us, we all have a cell phone, and most of the applications of computer vision on the edge are done with, for instance, cell phones or tablets and so on. In summary, here in this link down here, you can actually check a really nice comparison between sensor models, not only of Sony, but also of On Semiconductor and other brands. And I find it really useful because you can see, for instance, here all the topics that we have been covering and how they are related. For instance, the pixel size here, 3.45 micrometers, and how the higher the pixel size, okay, the better the signal to noise ratio. For instance, 4.5 micrometers can lead you to a 44.10 decibels, and how here actually is a little bit lower. So in this sort of charts, in this sort of tables, you can see, you can compare a lot of brands, a lot of sensor types, and so on to see what is the right choice for your application. Let's move to optics a little bit, to lens selection. Optics is a huge topic, as you guys know, but I just want to go a little bit through it. It's not my intention to give a whole speech about the physics of light and whatever. It's just about getting to know this topic. So these are actually, from my point of view, a short list of the minimum topics to start with lens selection. So first of all, we know that you rely on your computer vision algorithm machinery to correct for things like distortions, scaling factors, chromatic aberrations sometimes, and so on. But the more the lens fits to your application, the less headaches and frustration you will have. That's a must, I would say. Sometimes we are really struggling with our computer vision algorithms, but sometimes the right thing to do is to maybe to change the camera or the lens. Why quality is important? Two brands, as I was mentioning before, may have the same specs, but totally different performances. Of course, you can go through to the math on how to calculate the right lens depending on your working distance, depending on the horizontal or vertical field of view, and so on. But the thing is that there are so many variables involved in an industrial application that at some point, if you go to the formulas and you make the hand calculations, the results are not going to be actually so specific. The result of these calculations may throw you certain results that actually fit to a variety of lenses. So there's not like one single right answer for the hand calculations, so to say. So as we will see in the next slide, a good idea is actually to use some tools, some free online tools that help you actually calculating these features for your lens. Nonetheless, I think that calculating the minimum sensor resolution based on the smallest features you want to detect is extremely important. This is one of the main things to consider, for instance, in our applications in the company, because we want to detect the smallest damages in the vehicle's bodyworks. So it's extremely important to look for the minimum sensor resolution. Otherwise, if we want to detect a really tiny scratch, but it turns out that the sensor resolution is not good enough for it, then we will never see it. It might be confused only with noise, for instance. Okay, so how you calculate sensor resolution? It's pretty easily the field of view divided by the smallest feature. In this case, if you don't have the entire field of view, let's say the entire area of view, so to say, you can actually just feed the value you have, for instance, the horizontal or the vertical field of view, and it will give you an estimate of what the minimum sensor resolution might be for your application. Okay, the same thing for the sensor size. So look at the pixel size on the sensor's datasheet and multiply it by the calculated resolution. So once you have this resolution from the previous step, you can just go to the tables, like this one right here, and check for the specific pixel size, for the pixel size, and multiply it by the calculated resolution. You will get what's the sensor size you need, or the one that fits kind of good to your application. Once the camera is selected, you can use the sensor size to calculate the focal length, which we will see further. Really important, take your time to study all the possible variables. Then pick wisely a few lens options, and don't expect first try success. It's really important. With these online tools, you can find on the internet, for instance, with these manufacturers, Basla, end monoptics or FLIR. Basically, they ask you for the same values. For instance, the minimum working distance, the focal length, or the horizontal or vertical field of view, and so on. But the reality is that these online tools will give you actually a set of lenses as a result. So they will not give you, hey, you know what, this is the one and only lens that fits exactly with your application. You need to give it a try to at least 2 or 3 different lenses. Sometimes to buy it if the supplier don't want to lend you, just to borrow you the lens, you will need to buy it. But the more you constrain your possible variables, the less you need to be trying with different lenses. This is important. Some extra tips regarding lens selection. Well, these are actually things that have helped me a lot during my let's say my last 8 years. Find the best trade-off between the working distance and the field of view. You might have an application, for instance, I would say object detection. It's actually a good example, or anything related with image recognition, where if you have the lens super close to the objective, to the object or to the scene, and you're expecting to recognize something in the scene based on, for instance, on some color or some texture. When the lens has a lot of distortion and the lens is not actually a good quality lens, it may happen that the cones of light at different frequencies are actually bouncing, so to say, in such a way that you will end up with some optical aberrations, which is something you really don't want for your application. So as a rule of thumb, I would say go for a distance, for a working distance of at least twice as large as your field of view. This is a practical rule of thumb that will really help you a lot. And the second, your lens aperture. Sometimes we don't remember that a lot of lenses have a DF number. So the lens aperture is your friend. Use it. A larger depth of field requires a larger f number, and this is also really important because actually I have seen applications of object detection with super old cameras back in my country. These cameras actually don't even have autofocus. So at some point, if the object gets closer or more distant to the camera, it might get out of focus. So it's really important that if you set properly your f number, the object you're looking at in the scene will stay in focus, at least for a specific depth. And this is really, really interesting because maybe you don't need, for instance, to inspect, let's say, bottles or whatever in a conveyor. Maybe you don't need a varifocal lens, you just need a lens that actually can be tuned in the sense of the amp number, such that if the bottles are, let's say, bigger or smaller, you will have no problem because the bottle will stay in focus no matter the distance to the camera. Finally, the lens performance curves are the ultimate documentation to read when you're selecting a lens. There are a lot of curves like this you may find in the documentation of the lens. From my point of view, the two most important curves are the MTF and the distortion versus image height. And well, the first one here on the left-hand side, basically what it tells you is like how good the lens resolve for a specific image sensor resolution. Okay, and because it's possible that when you're, let's say that you have your camera and the camera has 5 megapixels, and so you need to select a lens for that camera. But when you go to the data sheets, to the specs of that lens, you will see that it says this lens is good for up to 5 megapixels, for instance. Why if the size of the lens, for instance, actually fits the mounting of the camera, why it says that is good for 5 megapixels? Because it actually resolves for that specific resolution better in specific ranges. So this is really important. It also it's also related to the construction of the lens itself. Also, in the right hand side, you can see the distortion versus image height. So this is basically how the objects will bend, okay, so to speak, how the objects will bend depending on the image height. So yeah, I think that most of the guys in the audience are familiar with lens distortions. But a nice way to see it just in one shot is through these plots, through these curves. Finally, as we were seeing here, consider all tricky scenarios. I want to show you an application I was working with around 4 years ago, also in the sense of under vehicle inspection systems, how the lighting conditions can actually change so drastically from one place to the other, and how the depth of field is extremely important for this sort of applications. You have a fixed camera on the ground on a device. The camera is actually looking upwards. Yes, you use a fisheye lens. Basically, that's the basic concept. But the thing here is that a car that is going to be scanned, so to say, we're going to be stitching these images together until you get a composite image. But the important thing here is that in the right hand side, you see a typical compact car. So the clearance between the ground and the underbody and the understructure could be something around, let's say, 25, 35 centimeters. But this same system is also capable of scanning trailers, for instance, or buses and so on. So of course the clearance is quite higher. It can be actually more than 1 meter. So having this distance, having this difference between 20 to 30 centimeters to more than 1 meter and to stay in focus is actually it's not so easy. So this is the importance of at some point imagining all the possible scenarios you may find in your application. Maybe here the images are not so you cannot see in this presentation, but actually if you zoom in the lower image, for instance, you can see every single detail of the car so clear that you can even identify each of the screws there. So for the case of detecting bombs, weapons, or drugs, this is a super nice thing to have. Last but not least, illumination or lighting is a really difficult topic also, because sometimes you just go through different options and you don't necessarily find the right one for your application in the first try. But it's important to know what are the typical lighting configurations you may find in the market. Backlights are typically used for inspection of in production lines, for instance, where you need to see the shape, the silhouette of the objects. Also, bar lights are actually for more narrow spaces or for other sorts of applications that require directional lighting. For most of the applications I have been working with, diffuse light is actually the way to go. Of course, it's actually somehow similar to backlight in the sense that it gives you a diffuse pattern, but the difference is where you locate the camera. For instance, for the diffuse light here, as you can see, you can even locate your camera in the middle, because the camera is going to be looking in the same direction as the lamp, whereas in the backlights it's exactly the opposite. You also have ring lights that actually help you to get rid of shadows in 360 degrees. So this is really good when the object you want to see is actually smaller than the diameter of the ring. This is a really good solution for it. The linear lights are typically used for line scan cameras. So you can actually be turning on and off the linear lights in accordance to, for instance, to a measuring system, a measuring device like an encoder, for instance. And finally, the general purpose lights are the ones that we all know. So usually this is the one we tried the first. And then when we see that the situation is not working as expected, then we start looking for the other ones, right? But well, basically, that's pretty much everything. That's what I wanted to talk about today. If you want to go deeper into the topics, I strongly suggest you going to the Vision campus of Basler, a German company. Turns out that there are a lot of really nice German brands in the market of machine vision cameras and lenses. And for everything related to optics, I think Edmund Optics is one of the leaders in the market as well. So I think this is also a good option.
Excellent, Rodrigo, and absolutely fantastic presentation. I know we've had a couple of questions come in, but I think, presentation wise, we kind of went kind of on time. So we have 3 questions to ask you for the Q&A session after. So everyone who has asked a question, we will come around to it after the final presentation. But I suppose for next, carrying on, we have Jean-Lee Tao. So those who don't know, Jean-Lee has a PhD in computer science from the University of Auckland. Before moving into the industry, she was a researcher and a lecturer at the Auckland University of Technology, and now she's working as a computer vision engineer and machine learning engineer at Virtual Retail. So I'd like to now welcome Jean-Lee to begin her presentation.
Thanks, Anthony. Okay, let me see. Oh, trying to share my screen. Okay. Somehow it doesn't. Got a bit trouble, can't see my PowerPoint here. Give me a second.
No rush, Jean-Lee. Just yeah, we've got you here.
Go. Yep.
Good luck.
Thanks. Hey, yeah, thanks for the introduction. Just give a little brief overview about my project before. So during my PhD, I was working on vision-based object tracking. The subjects were pedestrians, vehicles, and the fruit flies. So after submitting my thesis, I joined a short project with AUT, which is analyzing the Antarctica vegetation from videos recorded with drones. After graduate, I joined Crown RTC. It's a forklift company. And in this research center, we develop indoor autonomous forklifts. I was focusing on 3D feature reconstruction, localization, and a little bit of sensor fusion as well. 2019 September last year, I joined Virtual Retail. So VR is founded in 2016 by Ling Wan and Benedict Lei. It got fully acquired by IFM in 2020. We have two projects going at the moment, the body measurement estimation and the IFM mate system. So the body measurement estimation is the initial project. We developed deep neural networks to estimate body measurements from 2 RGB images with height as prior. And the model contains segmentation, 3D reconstruction, and regression modules. With the online shopping getting more and more popular, there is actually a large portion of product got returned because of the wrong size. So this application fit right into this scenario. Currently, we're focusing on size recommendation. We actually work with a few partners, try to integrate our model as a backend, or they can directly use our phone application. This is not all, of course, it's also potential being used for customized outfit, style recommendation. Unfortunately today, I will not talk more about this project. If you do interested in using the product or know about this project, definitely get in touch. So the IFM mate system, this project we started last year. There are many big warehouses. The manufacturing line have the automated process to package the product. But in the small to medium warehouses, they are still manually packing components for a product. So the mate system is developed to provide individual guidance to assist packaging work procedure. So here is an example setup of the mate system. Here is the bench. Can you see my cursor? This is the bench, and then the camera is mounted on top and pointing downwards. There is a monitor and a processor. So it's all on edge. There's no cloud computing involved. This is a video showing an example case. So this monitor here shows the camera view overlaid with the region of interest. This is predefined by the user. And the highlighted regions are the relevant areas that you should pick items from. In this case, this is the cable and the manual. So we have a hand detection running on the back end to verify whether this areas got picked. So once these two areas picked, then the next relevant areas would be highlighted. In this case, this is a label. So with different products, the picking and packing procedure will vary. If the system, when you initialize the mate system and predefine working procedure, and then this can be used to trying for a new packaging task. And also working for packaging for 8 hours a day can be really tedious and prone to mistakes sometimes. So the system can also do a real-time alert when there is a mistake. So this can avoid rework. The system is currently available. We have about a dozen of them deployed inside IFM. For the previous 2 months, we try to get external customers on board. Yeah. Okay. So next, I'm going to talk about how we actually develop the hand detection model as the backend for verification. The most relevant research area is the 2D object detection. And one category is the region proposal network-based methods. Faster RCNN was proposed in 2019, and here is the overview of the network. It takes the image as input, goes through the convolution layers, it's also called an encoder. You get a feature maps, and then the regional proposal network will take the feature maps and predicts sparse proposals, basically bounding boxes. And then those proposals are combined with the feature map passing through to the classification and regression stage to get the final detection results. More recently, the Cascade and Dynamic RCNN tried to push the limit of detecting better bounding boxes, meaning have a better aligned box with the object. So after the regional proposal network, the RPN, you got sparse proposals. This is denoted by those colored boxes here. And normally you will apply a intersection of union threshold between the prediction and the ground truth to select a subset of proposals for the second stage, classification and regression. In this case, it's the green boxes that got selected. If you want to have a good bounding box location, bounding boxes, then if you increase the intersection of union threshold, you will have selected a better quality proposals for the later stage. There's a better chance for the model to learn a better quality bounding boxes. But at the beginning, the RPN is not performing that well. So it's only predict very sparse proposals and not really good quality. When the training progress, it learns, so it predicts a better and more proposals. So this dynamic RCNN proposed a very intuitive idea to apply a dynamic thresholding. Basically, it's trying to analyze how good is the current predicted proposals are. If they are good quality and good amount of proposals, then you can increase the threshold to get a better ones. It's quite a simple idea, but works quite well. Here is the results. It's actually works the best on the ResNet 101 deformable convolution network. But interestingly, compared to the Cascade RCNN on the ResNet 101, it is not that much better. It's actually worse. So, but the Cascade RCNN is using a different technique. It's adding more detection head, is heavier as well. So if you're interested in having a better quality bounding boxes detected, these two papers might be interesting for you. Another interesting one is the context RCNN. First of all, this is not an online method. It takes the current frame and the adjacent previous and future frames as local guidance to guide the current frame detection. Also, it uses a long-term keyframes to do this guidance as well. So what's the long-term? The long-term keyframes can be selected, for example, from different days, but the same time of the day, say noontime. And the choice of this long-term keyframe is vary from sequence to sequence. So it's more details in the paper if you're interested. With this tool, they're using the transformer standard attention module to combine this information to get the detection. Here is the result of the over 3 data set they tested. It's a very large margin compared to the single frame baseline. But of course, this is not a fair comparison. The single frame is only have current frame, but the context RCN using like the adjacent frame and even some frames far from the current frame. If you are working on analyzing offline videos and try to get good results, detection and with some assistance from the sparse distributed frames, this could be a framework would be really interesting for you. The regional proposal-based methods is also called a two-stage methods because it has the regional proposal stage that propose the region of interest or the proposal, and then it's classify and regress on that on the second stage. This don't have a fixed inference time. So if your first stage, the proposal propose more bounding boxes, then it's heavier for the second stage to process. So this is one of the reasons that this group of method is not used for real-time application, but they have their own special case use as well. Anchor-based methods is also called one-stage detector. Here, this flowchart shows the difference. It also has the input, the backbone, got the feature pyramid aggregation, and instead of having a regional proposal network, it uses anchor and sliding window technique to get very dense proposals for the classification and regression stage. So YOLO V4 is one of the one-stage detector, and it's proposed this year. It's actually tried quite a few different techniques that was published in the past couple of years. And for instance, they used the cross-stage partial connection on the backbone for the darknet and ResNext 50. Some augmentation like mix up, mix cut and crop, and label smoothing, and also mesh activation, pan path aggregation. So it's test out a bunch of stuff, and it's a really solid paper, and they did a really good ablation study. Like they separate out each item, almost each of them, like to see if you're adding this in, for example, the certain augmentation, how the performance is got improved and how much it's got improved. It's really good paper to read, actually. The scaled YOLO V4 was published 2 weeks ago, I think 2 to 3 weeks ago, and sets the new benchmark for this group of method. There are many devices available in the market depending on your price range, right? If generally the more expensive ones have a better capacity to process faster and larger models. So if the model can, when you develop a model, if you can scale the model according to a certain device later, that would be a really useful thing to have for industry application. So to be able to do the scaling efficient, that is a specific compound scaling method proposed for object detection framework. You probably heard about efficient net, which is scaling, a proposed compound scaling for the backbone structure. Like you can scale the image resolution, the depth and the width of the backbone in the compound way. And the efficient DAT take a step further. Instead of just the backbone, it also scales the feature aggregation pyramid, like the neck, it's called the neck, and also the prediction, the classification and regression head. So the efficient DAT was setting a benchmark for a long while with the largest model, although it's really slow, but it's kind of performing well. And then the scaled ULV4 P7 model, it runs actually slightly better than the largest model of the efficient DAT, but twice as faster. So very interesting paper to look at. Here is the P5, P6, and P7, basically the three models here. It follows the ULV4 structure quite a bit. It's still using the cross-stage partial connection in the backbone, but it's not using the darknet 53 anymore. It's changed the structure a little bit. Also, it applies the CSP on the feature aggregation part. Yeah, it doesn't sound that complicated, right? But it's improved the performance quite a bit. So what's the CSP? It is taking the convolution, it takes the feature map and then split the channels into two parts. In this case, it's half-half, and then directly pass part of it to the later stage, but the other half is going through the convolution box. Yeah, so another way, different from the compound scaling, they actually stack modules on top to get a larger model to achieve better performance. So one interesting experiment they did is like you trying your data set with only the ULV4 P7, and then you can discard the top two stack, and then you get a P5 model basically. And then this model, you train with P7 and just get rid of the top two stack and apply it. Compared to directly trying a model P5, it's getting a better results, the better performance. But of course, this is on the condition that your image resolution is in the middle range from 400H to 800. That's the image resolution we look at. So this would be quite an interesting thing to test out. If I could have a model and then I can train once and discuss certain parts and then deploy to a device that's kind of have less capacity. So yeah, this is definitely a quite interesting paper, and we are looking at it at the moment. So the anchor-based methods is actually quite popular in real-time application due to the balance of between the efficiency and accuracy. But with the anchor-based method, the objects detected are normally have the shape similar to the anchor size and aspect ratio that you predefined. So this kind of is a limitation, someone say. That if you have a large object which don't have a corresponding anchor size defined close to that size, then this object will not be detected. So the third category is anchor-free method. Because they don't require anchor, it's potentially more flexible for the object scale and aspect ratio. So they still have the same, you get the input image, you go through a feature pyramid, you go through the encoder, and then these features are passed through the feature pyramid, and then you pass through to the head. And then in the regression head, you don't have any anchors. It will directly regress from a pixel about the 4 distances to the image border, to the object border. This way, you don't have any reliance on the prior defined sizes and aspect ratios. 2 weeks ago, again, there is a very interesting repo published, NanoDet. This is based on the FCOS framework, and they optimized this to run on a mobile ARM CPU with a detection rate of 97. That's crazy, 97 FPS on mobile phone. Definitely check that out. It's quite a cool repo. Different from the FCOS, the CornerNet proposed, this actually framework, proposed to predict the top left corner and the bottom right corner, like this, and then pair these two corners based on a learned embedding to get the detection. The CenterNet is an improvement on top of CornerNet. It's proposed to use you predict also the center of the object. To kind of this idea improve the performance a little bit as well. Anchor-free methods are a very interesting direction. But in general, the performance is not as good as anchor-based methods. So yeah, but still quite interesting. And there is actually another new, in the last couple of months, new group of method is based on transformer. I didn't include the slides here. Basically, people apply, you don't need convolution. Well, you still need convolutions. Layers to get the features, and then you can pass the features to the transformer to use the transformer attention to do the detection. Absolutely cool paper to read on, but we will definitely keep an eye on that area. But I think the transformer might be more suitable for lower level vision tasks like super resolution, DRAM, defog, etc. So after selecting a model, a method, we need to adapt our data and adapt the model to our data set and also for our use case. So transfer learning or pre-trained model was a basic technique like almost everyone use. Until in 2019, there's a paper published, Rethinking ImageNet Pre-train. This paper basically saying pre-training actually is not helping your model to improve. It's basically help your model to converge faster. We actually tried without pre-trained models. For our case, our specific case, the pre-trained weights actually help both the convergence and the performance. So it really depends on the application, I think. For our case, because you can see we had the workbench have very relatively simple background. And with the ImageNet, they have very cluttered background. So with the pre-trained weights on ImageNet, it kind of helped the feature representation part a little bit for our case. Secondly, we labeled our own data set, and we actually want to have a bit more specific area from the hands. So we're actually wanting to estimate where the hand is grabbed at. If you have a really tiny region of interest, you want to understand the fingertips area instead of just the center of the hand. So we modify the networks to the models to estimate the rotated rect and the waist location to roughly estimate the orientation of the hand as well, to give us a more precise location of the hand. The hyperparameter tuning part is quite important for industry application from my point of view. Everybody talk about overfitting is a bad thing, it's not necessarily bad if you have a very specific case that you want to overfit to that specific case. So hyperparameter tuning is sometimes prone to overfit your model to a certain direction. But I think it's a knife with two sides, like might hurt you and might help you, but you pick, right? If you have a good guess about your hyperparameters, and genetic model algorithms are quite common to use for people to do the fine adjustment, especially when your parameter space is when you have a lot of parameters to estimate, like if you got augmentation, learning rate, and also the post-processing part all in this bucket. It got quite a lot of them, and it's not suitable to use the Bayesian optimization to do this task. But if you got only a few of them that you are not quite sure about, then population-based training, Bayesian optimization could be something you could look at. We developed our model on PyTorch for deployment and also for the inferencing speed purpose. We convert the model to Onyx and also TensorRT, and then we deploy the model. Till here, we actually finished a cycle of one model deployment. Again said, we have a dozen of systems delivered in actively tested. At the meantime, we try to evolve the detection models with the latest, greatest, not necessarily always the best ones, but we try to keep up. And another thing is the data. We keep getting more data coming back, and labeling all of them is impossible and very expensive. So we look at the semi-supervised learning. Again, this is a paper really, really cool and published this year. If you have 10% of the data labeled with their proposed semi-supervised learning procedure, that's a green line. It achieves slightly better results, performance, compared to you give it 4 training set with 4 labels. That basically means like you not necessarily need to label all your data. That's pretty cool. And briefly, so what's the framework is about? The self-training, basically contrastive representation learning is really booming out, and pre-train, a lot of people using self-training to get the pre-train weights instead of pre-train the ImageNet classification task. That's training. So here, this part, again, they use the unlabeled data and do the self-training, or I call them contrastive representation training, learning. And then you get the pre-trained weights, and then you fine-tune them with your labeled data. And now you have a teacher model. Then you use distillation. You have the same structure of the same model. Then now you use distillation, use the output of the teacher to train your new model, and this model performs better than the teacher model even. So yeah, quite interesting procedure of training, and it works really well. And yeah, this is something also quite interesting if you want to do semi-supervised learning. As I said, I think I'm gonna stop here, and hopefully you learn something from this talk. Thanks.
Excellent, Johnny. Thank you for that. Again, we've had a couple of questions come in, but we're gonna go straight through to Jan now, who will then take us up to the questions at the end. So anyone who's asked a question, look, we will get to them after our final presentation. Jan, are you here? Oh, perfect. You're there. So for a final presentation of the evening, we have Jan Zwandowski. So Jan is currently the acting head of AI at CAR. Just make sure I get this correct. It's car.sw.org, which is the new central development company for Volkswagen. He's also worth checking out on Medium, as he's one of the top contributors for the Towards Data Science publication. But other than that, Jan, happy for you to take it away here.
Thank you so much, Anthony. Yeah, thanks also to Rodrigo and Jun Lee for the talks beforehand. Really interesting. Definitely learned something new. Okay, sorry, I'm just trying to figure out what happened here now with presenting the screen. Hold on, give me 1 second.
Maybe just cancel and reshare, because it's looking like it's sharing your screen, but it's just blank.
Yeah, just cancel it a little bit here. There we go. So let me share my screen again. Right here, share. Okay, this looks better, kind of ish, right?
Yeah, it looks good for me, Jan.
Okay, let's get started, everyone. Hi, thank you so much for coming in and joining me today for this presentation. Thank you for inviting me, Anthony. My name is Jan Zawadzki. I'm the acting head of AI at the CAR software organization, which is the central software development unit of VW. My talk today will be adjacent to computer vision and mostly about the steps before you actually get into a computer vision project. But before we get started, let me start with a little story about Frederick Taylor. I'm sure most of you have heard of Frederick Taylor. He is the founder of scientific management. And what made him famous is he was, first of all, the son of a Quaker family, a very gifted son. And he started to work in a steel production factory. And back then, like 100 years ago, producing steel was an art, right? It was a craftsmanship. Depending how the steel worker felt today, you could get more steel or less steel out of a certain steel block, because they would always change their ways of actually producing this block of steel. And Frederick Taylor, he was very upset at that, and he carefully analyzed each step that was taken to produce this amount of steel. And then he eventually perfected the method. And at the World Show in Paris, around the end of the 19th century, I believe, he showed that how you can, instead of gaining 3 meters of steel from one steel block, you could extend that to 9 meters. So you basically tripled the amount of steel that you can get from one steel block. And that was just mind-blowing productivity increase. And that set off the scientific management theory for the next 50, 60, 70 years. And I see a lot of parallels to the data science universe. So data science in my opportunity today involves a lot of creativity, artsmanship, craftsmanship and arts. And don't get me wrong, I do not want to create those Taylor-like terrible processes that he basically used to enslave, to a certain degree, so many people who work in the just production industry. But I do believe that the data science industry can benefit tremendously from a framework and from guardrails and how to actually set up data science projects. Exactly. So about me, acting head of AI at the CAR software organization. So I do believe that we are currently working in one of the most exciting projects in the entire world. So we are currently a company, we were founded half a year ago. We are centralizing the software development competencies of VW Group. They produce cars like Audi cars, Porsche cars, VW cars. And the basic idea is that we want to create a VW operating system which abstracts the hardware from the software and which can make it easier for software developers to develop applications and functions for the car. The goal is to grow until 10,000 people over the next 4 years. And we have been assigned a few $1 billion in budget. So I would call it a really well-funded, huge startup that we're basically working on. Okay, and for me, as a past, I have basically built up data science and AI capabilities at Carmick before, and have also a background in management consulting. And so I really focus on bringing the parts of business case and data science project management together. Now, why would we even care about data science and machine learning? Let me share with you how SoftBank, the world's largest venture capital fund, by far the world's largest venture fund investor, thinks about machine learning. Let's not talk about the profits or losses, but let's think about the framework. So SoftBank says that they want to invest in machine learning capabilities, and why? What's the rationality behind it? They basically look 20 years in the past, and there was a point where internet-based companies were valued at a 22 multiple, and then the dot-com bubble crashed because nobody could really figure out how to generate revenue from the internet, and the valuations decreased significantly. But the underlying driver that was driving up the valuations was that the amount of internet traffic, how much people use the internet, grew exponentially. And 20 years later, you see the red line, the amount of internet traffic has continued to grow exponentially, and so has the market value of internet-based companies. And that's the parallel that you can draw to the AI-based companies today. So AI-based private companies, startups mostly, are valued at a 17x multiple, and it looks like there could be a downturn in the future. Nobody knows, but potentially there's a downturn of the future. But what's the underlying driver of the AI valuations? It's the exponential growth in data. And if you look in the future with the IoT connections and just the hardware costs constantly decreasing and the capabilities of these hardware topics increasing, it's predicted that the general amount of data that will be produced in the future will grow exponentially. And thus there will be more opportunities to generate value from this data based on machine learning methods. So I think this is really powerful. And I think also a lot of companies have bought into the trend. So on the left side, you see some data. The Stanford has done a study and has basically analyzed how many people, how much private and public companies and also the public and private sector are investing into machine learning, and it has constantly grown since 2009 unto a staggering $80 billion or $1 trillion. A lot of money, anyways. And then the PwC survey from 2019, which basically surveyed CEOs from Fortune 500 companies, says that 77% of those companies plan to start or employ AI initiatives in the future, and only 23% say that they do not plan to start AI initiatives. So it looks like investment in AI is heavy, and it looks like there will be more AI projects also conducted in the future. Now drawing the parallel again to Frederick Taylor and how he basically drew the guardrails and the framework for scientific management. The PMI is the Project Management Institute, and they have delivered a very good framework, the PMP framework, for delivering traditional waterfall-based projects, right? And they've done an analysis, and those projects who followed the PMP guardrails, the traditional waterfall projects, only 11% of those failed. Now, if you compare that to how many AI-based and machine learning-based products fail today, it's hard to gather specific data. There's this rumor out there, which some Gartner employee tweeted some time ago, that 80% of AI projects fail. The only data I could really find to back this up was that about 50% fail, based on an IDC study in 2019. But from my experience with talking in the industry, this number seems to be about right. And you see there's quite a large gap between traditional project failure and AI project failure. Now, the machine learning workflow is for every product the same. First, you have to define the business case, then you need to prototype a solution, then you need to productionize the solution, deploy it, and in the end, you want to measure and monitor it. And my talk today is focusing on the very first step, because if you do all those wonderful things here afterwards, without properly defining the project, without properly defining the business case, then it's very likely that your project will still fail, even if you succeeded in those 3 steps afterwards. Okay, so I'm focusing on the first part here today, and I'll give a computer vision example also later. Now, how do you need to generally think about AI projects? What's important to me is that you first do some self-reflection. and that you think about the status of your AI, the status with AI of your company or of yourself right now, okay? So if you're a beginner, you need to approach machine learning differently than if you're a professional or AI first. On the left side, you see approximately the value that you can get delivered following along this AI maturity index. And this is mostly based on the virtuous circle of machine learning. So this is based here. So once you have a product, you have more users. The more users you have, the more data you can generate. And because machine learning is based on data, you can then use this data to create an even better product, get more users, more data. And this sounds just tremendous. Now, I think it's also really important to say that when you want to work with machine learning, if you're a beginner, it's very good to probably have a central team that develops machine learning POCs and just get started with machine learning. If you have successfully completed some POCs, you can move into the professional category where you actually want to bring a product into a machine learning based product into production. And then later, when you're AI first, machine learning is natively ingrained into your software products. And you, with every step, you think, how can you use machine learning to improve the product? And then you just have purely decentralized teams. What's also important to consider about AI projects is the AI project risk impact matrix. So we can basically classify this project as in high risk or low risk, and then look at the impact as in high impact and low impact. And we have the low risk and low impact project, which I would call solid starts. Those are projects, for beginners. Then we have the low risk and high impact projects, the holy grail projects, which everyone eventually wants to land. High risk, high impact projects. And then you also have high risk and low impact projects. And those are projects you basically want to never try out. So this is again the connection. So when you're a beginner, my recommendation is to start with low risk and low impact projects. Once you've successfully completed a few low risk, low impact projects, you should move to the holy grail category, or at least try to look for it. I'll give you some tools to basically figure out where your project falls next. And then once you've completed holy grail projects and you have delivered value with machine learning, then you can also move some of the resources into the calculated bet category, which is basically the innovation category. So if those projects pan out, huge reward. If they don't pan out, no worries, you still have the holy grail projects to back everything up. Now, let's look at some concrete ideas how you can actually go about ideating, evaluating, and scoping those projects. So when you want to come up with machine learning project ideas, you can use the first half of the double diamond framework. So first you want to discover as many project ideas as possible. And then afterwards, you want to look at the projects which you deem interesting and then narrow it down and narrow the problem space down, the solution space down to the projects that you actually want to work in. For the discovery process, I have found it to be very helpful to use a tool called AI the Game. This is provided by our friends from In the Pocket. You can actually create, it's a literal card game, and it has 3 different categories. So one is role, another one is tasks, and then the third one is value. And what you do, you basically gather a room of, of cross-functional experts. So it's always good to have people from the sales department, from the business development department, product management, engineering, some data scientists, some product owners, and get just a wide variety of expertise in a room. Then you assign those tasks, right? So one person can be the CTO, another person can be the COO. Then you assign certain values like, okay, what do we want to do? Do we want to increase revenue? Do we want to cut costs? Do we want to increase our engagement, whatever? And then you have different machine learning tasks. And then you can basically go through those tasks, like one says style transfer, then explains it. And in just 2 sentences. And then that person can think about, okay, could this task potentially help me as in the role that I'm in and with the goal that I have, achieve my goal in my current position or not? And then if you do it right, you get 20 to 30 projects at the end of the session. And then that's it. Then you have 20 to 30 project ideas after like an hour or 2 hour long session, and you have had some fun along the way. It's absolutely non-technical, so not all of those people need to know about machine learning, but those cards really explain it well what you can do with machine learning, and it just provides a stimulus to think outside of the box. Another methodology that you can also use is design thinking. I have personally not used it yet, but I do believe it's a good methodology to actually come up with AI project ideas. Next, then this is, if you take one thing with you from this tool, then I can just, from this talk is, then I can just say that it's hopefully this tool. It has helped me tremendously over the past 3 years, and I would not want to live without it. So this is the AI project canvas, and it is based on the business model canvas that was developed, I think, by this Oster guy about 10 years ago. And what you want to do is that you want to create a one-page overview over each project and answer the most important questions towards your project. I will go through each of the, I will go through each of the topics right now. In the middle, you have the value proposition. So here you clearly need to state what is the value that you're trying to create with this machine learning based project, right? I'm hoping that we eventually get away from, oh, I read a cool paper and I just want to re-implement whatever they have done, towards what is the value that could be created by re-implementing this paper. Then next, we need to talk about who's the customer. It's very important to think right from the beginning about who will actually use the product in the end. Then another topic I see that is often overlooked in the beginning is how would we integrate it, right? Do we have a microservice architecture where we could just deploy our model? Do we have to integrate it into a certain existing software stack? Because all of these, the integration at the end, all of these topics basically decide on how you approach the problem and the solution. Next, you have stakeholders. Do you need to talk to the legal departments? Do you have POs that you need to talk to? Does the strategy department know about the projects and how does it fit into their roadmap? On the bottom, you have the topics that are often frowned upon by engineers. So you have the cost and revenue part. We need to create a rough estimation of how much it would cost. And then we would also need to create a rough estimation of how much revenue it would bring in. Next, we have on the left side the data column. What do we know about the data? Have we worked with this data set before? Did we collect enough data? How much data do we need? Do we need labeled data? Do we need unlabeled data? What do we have? What skills do you need is another one. Do you need data scientists, data engineers? Do you need embedded systems developers? Do you need cloud engineers? And then at the end, a concrete output metric. So if you can define a concrete output metric, let's just say we want to reach 99% map score, then put that in here, and that would also help you very much answer the most important question about your AI project. And this is also all you can think about as a circle. I suggest you to start with the value proposition in the middle, move on to the customer and integration part on the right side. Then think about how would those customers basically pay for this product? How much would you have to pay to actually produce it? And then, do we even have the data? Do we have the skills? And do we know what we want to produce to actually create this output? Let's make this abstract example a little bit more concrete. So I have the idea of the AI audience analyzer. So back before COVID times, but even now through Zoom sessions, I would love to get feedback about my presentation. I would love to get feedback as in how many people listened to my presentation, how engaged were the people, what was maybe the distribution of gender, of age, of other topics, other demographic topics in the audience. And I think it would provide a lot of value if you could monitor the audience and then provide audience engagement insights for the speakers and for the conference organizers afterwards. Okay, so that's the thought. I put that in as a value proposition. Then who would be the customers? Well, on the one hand, it could be conference organizers. They could sell it as a feature to the conference speakers or also to the audience to give just more data about the conference and also to know about which speakers are really good and which speakers maybe are lacking some certain audience engagement skills. And then you could potentially also sell it to public speakers. How would you integrate it? I think there are two ways that you can integrate it. You can either do the cloud inference, or you might have to do the inference on the cameras that are there at the conferences. and that would be then an embedded device inference, and that would basically dramatically reduce the options that you have to actually bring it to the hardware. Who are the stakeholders? Well, it's never an easy topic to film people during an audience and to also create, gather data about the people and then to aggregate it. And then obviously the organizers of the events are also important stakeholders, because they basically have to create the paperwork that the audience allows it to be monitored. What costs do I imagine? Well, there will definitely be a cloud consumption to basically train the model and work with the amount of data that we have. And then we also have the salary for a data scientist, data engineer for 3 months. I just, suggested that. What is the revenue? So you can sell it as an SaaS business model. Let's just say 10 euros per month if ever you want, or for every conference you do a one-off payment of 99 euros. And then with enough scale, you can actually create a profitable business out of it. The data part is quite tricky. So I'm quite sure that there are open source data sets and open source models out there that could do some analysis of pictures of demographic distributions and engagement and emotion recognition. You would have to see how well this works also at a distance, right? And then we might also need to collect and label more data, which would be very time consuming and very intense. What are the skills that we need? Data science and data engineering, and the key metric still defined, right? So I'm not sure how exact the information has to be. If a rough indication is good enough, or if it has to be exactly, 95% average precision score, that we would have to find out by talking to more customers actually. And you see here's on one slide, you have the most important information that you know about the AI project canvas, about this project. And how does this help you now? So we had at the beginning the risk and impact matrix. And my belief is that the more of those fields that you can actually fill out confidently. So out of this AI project canvas, I think you can fill out 7 out of 9 topics quite confidently. The output metric and the data metric, those are big uncertainties. But the more topics you can fill out, the lower the risk becomes of your project, right? If you can have detailed answers to all of those questions, then it's definitely a low risk project. And if it's, the fewer basically answers that you have to those questions, the more risky your project becomes. Okay, so this is how you can score your projects then. At first, you've ideated many ideas, then you created this AI project canvas to the most interesting ideas, and then you can basically map them onto the risk impact matrix along the risk. How do we assess impact? Impact is not so easy to assess. I think we can use the RISE score, which is heavily used in the product management community. And RISE is short for reach, impact, confidence, and effort. And it's basically just a way to quantify the importance of a product. Okay, so reach would be how many customers will benefit from the solution. Impact is how much does this feature benefits toward our current goals. So this is very important. Impact is not equal to revenue. Maybe one of your goals is to increase just customer engagement, which does not directly translate into revenue, but could indirectly translate into revenue. And there you have a score between 0 to 3. Confidence, how confident are you that you can actually deliver it? And then you divide it over the effort by how much hours it takes to deliver the project. So for the RISE score AI audience analyzer, let's just say we could reach 250 people. Impact would be quite big, because for me personally, the goal is to become a better public speaker, and that would definitely help me reach my current goals. And for the project team, it would be also reaching their goals of, I think, if everything works out, creating a profitable business. Confidence, I think, is quite low, because there are a lot of uncertainties regarding especially the data and then the customer development part. So we haven't done enough there. And the effort, you derive this effort by, I think, using the one data scientist and a data engineer, and you have them work for a month, or like both of them for 3 months or for a quarter, or both of them a month and a half. And then at the end, you get a score of 0.52. And then you can compare the RISE scores of the different projects and place then your project on the risk impact matrix according to the RISE score, which is important for the intake, and then the AI project canvas, the boxes that were filled out on the impact side, on the risk side. Good, this concludes my talk. I hope this helped you a little bit today. I just wanted to encourage you to think about setting up the project the right way from the beginning. I also encourage you to think about the AI maturity level of your organization before you start, to what projects you should look at. Then I encourage you to use tools like AI, the game, or design thinking to just come up with many AI project ideas. And then you should definitely use the AI project canvas and the RISE methodology to assess the risk and impact of those projects. Thank you very much for your attention. If you'd like to follow me on LinkedIn, Medium, or Twitter, you can find my handle there. I sometimes blog about these topics, have less time now, but hopefully I will blog about it in the future again. And yeah, I would say over to you, Anthony, to discuss certain questions.
Excellent. Thank you so much, Jan. I really do appreciate that. So I suppose to kick off, I've got the very first question we came in was for Rodrigo. It's from Zishan. He had a question about how much is usable lifespan of industrial computer vision solutions, the approximate implementation time, and the approximate budget.
Okay, the last word was budget?
Yes.
Wow, okay. Well, that's a really generic question, I would say. I think finding a trade-off between implementation time, budget, and so on, it's at this point in time, I would say the budget is not necessarily a concern from my point of view. There are several brands really pushing in the right direction. You know, I think you can, depending on your application, of course, for the visible spectrum, there are cameras, for instance, for hyperspectral cameras, multispectral cameras that the price goes just crazy. In this sort of applications, I think the budget is definitely a concern. But for most of the common applications requiring normal cameras, I would say you can rely on the manufacturer to have some good advice, and I think sometimes in the order of weeks you can have a good implementation. So with a reasonable budget. So does that more or less answer the question?
Yeah. I was expecting a kind of rough answer until we kind of have a rough idea of the project, really. So we've got two more questions for yourself, Rodrigo. So the next one is from Farshid. So he said, do you have any tips and comparisons of stereo or / depth for cameras?
For stereo or depth cameras?
Yes.
That's a really good question. It again depends on your application. For instance, stereo cameras, which is actually the most common or the most, let's say, yeah, classic method to extract depth information. It started, yeah, I would say back in the early 90s or even before. Requires, first of all, requires a richer scene in the sense of texture rich scenario, you know, because of the way you extract depth from the scene. You actually really need to have a lot of features in your scene. So if you have a more challenging scenario in this sense, I would go for a depth camera, for a time of flight camera, for instance. There are more commercial time of flight cameras. There are more industrial ones. The companies I mentioned, like Basler, they develop their time of flight cameras. Usually the resolution is smaller. We're talking about BGA, but definitely the performance is quite good. So I would say the short answer is that depending on your application, but I would say that the most distinctive way is like how is the scene you're looking for. You know, if it's more richer in this sense, go for a stereo set, stereo vision system. If not, you can go for a time of flight camera. It will also depend on the availability of the interfaces, for instance. This is also something common. If you want to extract depth information with a low budget, I would say go for a stereo vision set. It will also depend on the budget as well. The resolution you're expecting to get, the depth of your working space, and there are several characteristics, but keep in mind that the way one works, one extracts the depth information, and the way the other one extracts the depth information. One is by receiving the signal that is bouncing in the scene, and basically measuring the time it takes to get back, and the other one is by extracting the visual information based on features.
Excellent. We got one more question for you, Rodrigo, before we move on to Jun Lee's question. This one was from Arun. He asked, can you give any more information on line scan cameras?
Yeah, sure. Well, let's say that the main difference to start tackling the topic, the main difference between line scan and area scan cameras. An area scan camera is the common camera we are all familiar with a rectangular shape image sensor. The way you talk about resolution in a common rectangular shape sensor is just by defining the height and the width, and that's all. The way a line scan camera works is just like one single slice of pixels and nothing more than that. You don't have basically a height in this sense. It's like if you just have one single slice. Usually the resolutions we are talking about here for the resulting image is quite higher than with an area scan camera. It has a specific niche of applications, the line scan ones. I would say high speed applications where you need to be checking, for instance, inspecting the quality of a certain wood. You know, as I was mentioning, let's say labels. You're printing the labels of, I don't know, bottles of water, for instance. So the production is like, let's say, 100 bottles per minute. I don't know. Yeah, but there are really one label after the other, one after the other. The thing is that this line camera is going to be pointing towards the scene, and it's going to be collecting the images in a transversal manner. So if the conveyor is passing in this direction, the camera is just going to be watching one straight line here in an orthogonal way. And then the system itself needs to collect a certain amount of data per time. So it takes like several one slice images, then it collects it, and then it retrieves it. So it's this whole process between data acquisition, collection of the data, and then to deliver the data actually is not only it's actually power consuming, and you really need a lot of resources, first of all. Then another thing is that in order to illuminate the area and to synchronize the illumination of the area with the camera acquisition, with the image acquisition, you need to count on another system to measure the rate or the speed at which the labels are passing through. So you require, for instance, in that sense, an encoder, an incremental encoder, for instance, to be synchronizing the data acquisition and to be synchronizing also the light, you know? So, because otherwise, if you don't have all these systems synchronized, the resulting images are going to be blurry. Or let's say that you're acquiring the images exactly in the point where the label was not on top of the camera. So you end up with an empty image. So there are a lot of aspects to consider in this sense. Nonetheless, is the most common camera used nowadays and since a lot of years for this sort of inspections, you know, for production inspections. So that's the difference.
Excellent, Rodrigo. Thank you. We do have another question that has come in, but we'll try and get through as many as we can before coming back. So if anyone wants to keep them coming, we'll try and answer them as many as we can before we finish up. So the next one's for Junli. It's from Jelavish. So Jelavish has said there is a startup from Drishti, a startup called Drishti, which are offering a very similar service to what you presented on. They've done a 10-week project with Hella. They stated that their results were pretty impressive. Have you ever heard of that company?
Actually, not.
Okay.
But I'm definitely going to check that out.
Cool. Second part to that same question is the direction of hand movement. Is it important? And if yes, do you use something like optical flow?
The hand movement is kind of causing issue, but we try not to understand the movement of the hand because we just want to verify whether your hand is inside and grabbing the box. So the movement inside the motion, like the optic flow, is not helping from that perspective. But the movement of the hand, because of the resolution of the image, actually causing issues because your hands are blurred. So short, we are not using optical flow.
Excellent. Next question for yourself, Julie. It's from Irina. She's asked, have you applied in production any models trained in a semi-supervised manner?
Very good question. That depends how we define semi-supervised. If we define semi-supervised with using unlabeled data, then yes, because these days you can do contrastive representation learning then without training, without labels on a big data set, and you can use that pre-trained model for fine-tuning. In that sense, yes, we used it before. But we haven't tried the last paper that I showed with the 3-stage with the distillation.
Excellent. Just one quick one there, Junli, before I move on to some questions for Jan, if he's available. Akshay has asked, would he be able to get in contact for you? If anyone wants to get in contact with you, what's the best way for them to reach you?
Email them. I will answer. I will pop my email address into the chat.
Excellent. So we'll just jump on to some questions for yourself, Jan. So the first one from Daniel. So does AI Project Canvas propose a selection of AI technologies for a certain project type? For example, whether you use an attention network instead of RPN. So for example, a shopper wrist angle detection in a virtual shopping mall.
Okay, yeah, very good question. And no, absolutely not. So the AI Project Canvas is supposed to be very generalistic, and it's supposed to help for every project that you could basically think of. And it also forces you as a data scientist to take a step back, right? So before going into the technical details, as in how you would solve a certain problem, let's really just make sure we have defined the problem correctly beforehand and then enter the solution space. Okay, so that's why intentionally we do not want to look into what models we definitely need because that's too far ahead. We just want to get the very basics, the very foundation of every project done at first.
Perfect. Another one for yourself, Jan, from Irina. She asked, would you explicitly address risks in the AI Project Canvas? And she points out she thinks it's an excellent idea.
Okay, I'm glad that you like your own idea. That's very good. No, I actually also thought about adjusting it a little bit. So the AI project canvas, I think, can be adjusted a little bit for internal projects versus then for, let's say, startup projects. But I would not explicitly include risk. For me, risk is the sum or the combination of the answers that you have to the other questions. So risk basically follows from filling out the AI project canvas.
Excellent. Question for yourself, Jan, from Jalavish here again. As a side note, she said, when you mentioned the steel market, she remembers that Clay Christensen starts his book, The Innovator Dilemma, with how disruption happened in the steel market. It was a very fun read. Her question is regarding the value proposition part of your AI canvas. In the business model canvas, Osterwalder uses another canvas, which is value proposition Canva, which is very focused on customers and the product. Can you please explain more value proposition sector in your section based on product and customer? And then additionally, how much do you think the data scientist has to or can be involved in this product part?
Yeah, very, very good question. So I think the business model canvas was developed first, and then later the value-based product canvas was a more stripped down, more focused version of the business model canvas. I do think that the value proposition is just one part in creating the AI project canvas, but it's, to my opinion, the most important part. So I haven't thought about actually creating also like an AI value based canvas, but that might be an interesting follow-up idea. Thank you for bringing that up. And then the second question was exactly if a data scientist should be involved. I think it's absolutely necessary and 100% mandatory that a data scientist understands the value proposition. Because if you are a data scientist and you do not know exactly why you're doing what you're doing, you will not be able to optimize towards the right topics. I do not see data scientists or employees in general as just key output metric optimization machines. You have to understand the context that you're in. Maybe you can get help, right? So the AI project canvas doesn't have to be filled out completely by a data scientist. And I think it should be filled out by a cross-functional team. But the data scientist at least has to inherently understand the value proposition. Otherwise, we will probably not create much value.
We have another question for you, Jan, on the area of risk. Is like, would you have any examples of each risk area in AI if we are starting to build product at individual levels?
Mm-hmm. So the biggest risk that I usually see is not knowing about what data you have. So that's on the technical side, right? So the biggest risk is always not clearly defining the business problem, but then on the technical side, it's just very risky when you A, don't know what data you have, and if you have data, and B, if you haven't worked with the data before. If you know that you have a data set with user profiles, with demographic information, it will be a very easy game, very fair game, right? In the automotive industry, we know what data we will get from the cars. And so it's not, we know that we can work with this data. So understanding your data, if you have a good understanding of the data, that lowers risk dramatically. If it's the first time that you ever work with this data, and if you have many question marks, if you even have the data, I would almost immediately put it into the high risk category, just speaking from experience.
Excellent. I just wanted to say, Irina wanted to know, she does like the AI project canvas idea. It was maybe my accent that came across. Rodrigo, are you still there?
Yes, I am. Of course, I was just answering one of the questions. Like, I was typing my answer.
I may be possibly asking the same question here. So it's a question from Daniel. He said, great slides, practical advices on machine vision, hardware, depending on computer vision algorithm feature. Thank you. He was asking, have you ever worked with Cognex cameras? And what do you think of them, especially compared to listed state-of-the-art cameras in terms of S&N?
Yeah, I was actually, I will basically read what I wrote. It's, well, thanks a lot for your words, indeed. I have worked with Cognex a long time ago. It's actually one of the brands that have been in the market for so many years. I have seen them in so many exhibitions regarding systems for packaging, for security, for control systems, for a bunch of stuff. I think the whole package they offer, not only hardware, but also the interfaces, connectors, and the software, I think it's pretty straightforward to work with. To be honest, I don't know about, for instance, the trade-off between price and performance, because I was not the one choosing those cameras. But I think it's definitely a good solution, like a single key solution, so to say. So yeah, definitely, if at your company they are considering them, I would say give it a try.
Nice, thank you. This question from Akshay, he doesn't say who it's for, but he said the parameters explained for camera selection, I guess it could be you, the parameters explained for camera selection processes will hold good when use cases in the wild, such as front-looking cameras in automobile.
Front-looking cameras in auto, so maybe he means like the cameras that are installed like in the front bumpers for.
Yeah, I guess when he says in the wild, it's a fresh production environment, maybe.
Okay.
I don't know. Actually, if maybe you have, oh yes, he does. He means fresh production environment. So how do you explain the parameters for camera selection if you're going into a fresh production environment in the automotive industry for front-looking cameras?
Well, I think the tuning of parameters actually apply for, I would say, for any situation. Definitely. I mean, the more you get into the hardware, into really the intestines of the camera and everything, the more you see that those parameters are completely necessary for whatever application you have in mind. But I think my best advice would be try to consider again all the possible implications, all the possible things that might go wrong in terms of your lighting system, in terms of noise, everything you can imagine, and go first of all to the image sensor. That's something that will actually help you a lot and will avoid a lot of headaches. So and actually there was also another question I saw somewhere there about going a little bit deeper into the camera parameters and some firmware of the.
Yes, that's from Pierre. He asked it out in multiple instances. So yeah, he asked about how do you go and choose your parameters and more details about the lenses and the lens choice.
Yeah, I didn't went to it because of the lack of time. I mean, it's a huge topic, but definitely there are some other parameters. Most of the manufacturers, again, like Allied Vision, like Teledyne Dalsa, Basler, and so on, they have improved their firmwares. They have improved their SDKs and so on. They were buggy, yes, of course, there were like a lot of software in the market, but I think I totally suggest using them. For instance, some other parameters I never mentioned, like the exposure time, extremely important. The gain, extremely important. All those sort of things. Maybe in the future we can talk more about that, or you can just go to the links I posted, and so you can see more about it, because we have just a limited time.
So just one question / request for Jan from Genevieve. She was wondering, would it be possible to be involved in developing one of your AI canvases for fun? Look, maybe what's the best way to reach out and ask that request?
For sure. So we're expecting, going to be a father soon, so my time is going to be even more limited, but I also love to collaborate on certain ideas like this. And yeah, just reach out. Best way to reach me is LinkedIn. It's always good if you write a message in the connect request on why we're connecting, and then let's see if we can basically talk through certain ideas of how we can expand this. I also haven't adjusted the AI project canvas in over a year, so I think it might even be due for a little revamp. But yeah, please reach out for sure.
Nice. There you go, Jelavish. Hopefully you can get connected. We have two questions. One just came in, but one's been there for a while. It's from an attendee who hasn't left their name. She said they've asked which intermediate projects would help build a stronger understanding towards computer vision. So for example, if you're looking to do your master thesis topic in this area. I suppose that's an open question for Rodrigo, Jan, Junli. Maybe there might be bias. We'll see.
Maybe I can just start. Just my perspective might be a controversial one, but obviously neural networks and convolution neural networks are state of the art for computer vision. So that's really important to understand those. But if you're writing your master thesis, I would encourage you to actually do a comparison of traditional methods for a very specific use case with machine learning. So it's going to be hard because you have to understand two totally different theories, but like you wouldn't believe how often people always jump to neural networks when certain Kalman filters or other more traditional methods would do the job probably even better and much quicker. So just understanding the traditional computer vision methods together with neural networks, the state of the art, convnets and whatever new cool stuff might come out, I can just encourage you to do that.
I totally agree with Jan. If I may add something really quick. I think for a master thesis, I think something more related with an application would be good, would be definitely good. And yeah, definitely convnets are everywhere. Sometimes you don't necessarily need to apply the top state of the art, like architectures like Junli mentioned, which are fantastic, but at some point you need some expertise to really deeply understand what's going on under the hood. So yeah, comparing some algorithms with things that are not the state of the art. Like in my very personal case with control theory, there were a lot of new suggestions coming up like every month, and they were all comparing them against a PID controller, and most of the time the PID controller was performing better. So yeah, definitely I agree.
Well, maybe I need to propose something different here. No, totally agree. Actually, it don't really need a hammer for, not something that like a nail. With a master, I always, every time when someone come to me say they want to do a master project with me, I will ask them, what do you want after your master thesis? Do you want to do a research? I mean, do you want to continue on research direction, or you actually want to get a job in certain area? I guess if you do want to go to the research direction, then you probably pick the most cutting edge, which currently probably is the neural network direction. But if you do want to just for job purpose, or it's more like you should align yourself with the certain areas that you want to work in the future, and then as said that you find a good application and do the applied part instead of the technical or theoretical part of the poking. Yeah.
Excellent. Well, look, I think that's going to do us for tonight's event. First off, I want to thank Rachel for being our sign language interpreter, Rodrigo, Junli, and Jan for your fantastic presentations. I want to use this opportunity to thank all the attendees for taking the time to attend an event, particularly after work when you're working from home all day, to say a happy Christmas and a happy holidays, because most likely I'll be speaking to everyone after December. And I look forward to doing a lot more events like this over the next year. And I look forward to getting some going in person again, which that would be really nice. But thanks everyone. This is the SOD.AI Computer Vision in Production webinar. I'm signing off. It's Anthony. Thank you.
Thank you all.
Thanks. Stay safe.